So this n and this n cancels, so this very contribute nothing to the motion, overall motion of these two bodies. R1 cancels m1g, R2 cancels m2g, so these contribute nothing to the net acceleration or net motion of these two bodies. So we will find that the only force which is contributing towards the acceleration of these two bodies will be this F. Okay, because this F is not cancelled out. All other forces are cancelled out. So F is the only force. So this F is the only force contributing. This F contributes to the combined acceleration of the two bodies M1 and M2. Okay, so that means this force applied, which is applied now, we have two bodies like this, M1 and this is M2. Force is applied on this F. So only force which is contributing to the acceleration, because if this force acts on M2, that will result in the motion of on M1, that will result in the motion of M2 also, because these are in contact, and contact forces, all other forces are cancelled out. As you have seen, this very cancels this cancels this, n cancels this very n. Okay, so the net force, the net acceleration is caused by this very force, and these two bodies act as a single system with mass m1 plus m2. Okay, so this very body acts as it is a single body now with mass m1 plus m2. So we know from the second law of motion says that force equal to mass times the acceleration. Okay, mass times the acceleration. Since we are dealing with the in the horizontal direction only, the force is acting on this direction only, so we will take these as scalars, as this is only the one-dimensional problem, not the vector one. Okay, even though this is a vector, but it's only the single directional. So that means F will be equal to mass of the system. Now we have two bodies at a time taken. Okay, at a time. So we have m1 plus m2, the total mass, that is m1 plus m2 times the acceleration. So this is the acceleration which we are unknown till yet, because force is known, which is given in the problem as F. The mass of the two bodies is given, so we can calculate the acceleration. So till now we have got force acting on the system as mass times acceleration, that is m1 plus m2 times the acceleration, which further implies that the acceleration will be equal to the force upon mass of the two bodies, that is mass of the system. So this will be the acceleration caused inside the two bodies. Okay, so the two bodies, that is these two bodies, will be accelerated with an acceleration of a given by this very formula here. Okay, so this will give the acceleration of the two bodies of m1 plus m2 as a system, but we have to find the contact force here, the contact force between these two. So that very force will be given, since force is acting only on this very body F here, isn't it? So this very F causes motion in M1, so that in turn causes motion in M2. So actually the force of contact is affecting this very body M2, this very body M2. So we have to find the force which is acting on the M2, that is the contact force, because this very force acts only on M1, and the second body is an intern due to the effect of the bigger mass which is in contact with that, that very causes the motion in M2. So we have to find the motion, we have to find the force acting on that very M2 body. Suppose the force acting on the M2 body, that is the force of contact. We have represented that F prime will be given by second law of motion, that is m times acceleration, and m here is m2 times the acceleration. Since acceleration, this very acceleration is same for both of the bodies, because both of the two bodies are combined or moved in combination due to the force F. Okay, so this very body M2 will be moving with the same acceleration as that of the two bodies, because these two bodies are set in motion in a combined state. Okay, so this very acceleration will be same for this very body or as of that of the whole of the two bodies as a system. So the acceleration of the system, here I will write it system, acceleration of the system is given as this. Since acceleration of the system is same as that of the acceleration of m2, which is equal to the acceleration of m1. Okay, because all the accelerations are same. This m1 is moving with the same acceleration as that of the m2, and m2 is moving with the same acceleration as that of the combined system. So this acceleration is actually this. So we will get F prime equal to mass times, that is the mass of the second body, multiplied by acceleration of the system. Here I will write it down, it will be same as that of the system. It is F by m1 plus m2. So this will be the force which is exerted on body m2. So this will be the force on m2, and that is the force of contact. Force of contact between m1 and m2. So we have calculated the force of contact from second law of motion between these two bodies which are given in the problem set. Hope you have got that. We'll try to solve another one in the next.